You probably know that acids are dangerous chemicals. How? Just look at this metal. Before dipping it into some acid and just 1 minute after doing so. Acids are termed to be corrosive substances because they eat you up. What makes them so? You can find out in this video, so stay tuned. Assalamu alaikum everyone, this is Fahd Ansari and I'm here to help you conquer chemistry. Before we begin today's video, I just wanted to tell you that a lot of you haven't subscribed. So if you're one of those people, please do subscribe to the channel so that you don't miss out on any important and useful chemistry video. So without further ado, let's begin. So this video is about dative covalent bonding, and we have already covered covalent bonding in a previous video. If you haven't watched that, you should go watch that first before moving on with this one. So dative covalent bonding basically involves the sharing of electrons in a bond pair that originates from one of the atoms, right? So normally you have two atoms sharing a pair of electrons. One of the atoms gives one electron, the other atom gives the other electron. But in this case, the bond pair is coming from just one of the atoms, right? This is also known as coordinate bonding, right? So we'll look at some examples to see what I mean. So remember when I was talking about acids and how they're so corrosive and that they eat everything up in their path, metal or flesh or whatever it is? Well, what happens basically is that when you dissolve an acid in water, you have plain old H2O, right? We have seen this example in the previous video that hydrogen and oxygen share one bond pair. And we know that oxygen is at group 16, so it has 6 valence electrons. So if two of those electrons are used in bonding, you have the remaining 4 as lone pairs, right? So this over here is a bond pair, and over here we have a lone pair. So what happens with this water molecule is that it reacts with a hydrogen ion from the acid, right? And basically what happens is that the hydrogen ion does not have any electrons of its own, right? So the H plus ion basically consists of just one proton and no electrons, right? So if it has to bond with a water molecule, it cannot contribute any electrons of its own. So this lone pair will now become a bond pair, and this is basically a dative covalent bond pair, right? So what happens as a result is that you get this giant polyatomic ion with the water molecule and a hydrogen ion giving you H3O positive, right? So around this diagram, I'm going to write square brackets, and I'm going to show the positive charge on this entire thing. This is basically H3O positive. That comes up when H2O, the water molecule, reacts with hydrogen ion from the acid, right? And this, ladies and gentlemen, is what is responsible for all the destruction that you have come to know about, right? This is called a hydroxonium ion, or hydronium ion for short. And this is formed by a dative covalent bond. Another way to represent this using the dashes is use regular single dashes for single covalent bonds, one bond pair shared between the atoms. So one bond pair is shared between this hydrogen and this oxygen over here, and the oxygen and this hydrogen share one bond pair. But if I want to show a dative covalent bond, over here I have this lone pair, another lone pair, and a hydrogen ion has no electrons of its own, so it will rely on the oxygen to use a lone pair to convert it into a bond pair between these two. So we show that using a single line but with an arrow on it, right? So this arrow, it points from the source of the pair of electrons that are used in the dative covalent bond. In this case, it's the oxygen that has the lone pair that is shared between itself and the hydrogen ion that has no electrons. It is electron deficient, but it needs to form a covalent bond. So this is the type of covalent bond that it forms, which is dative. So let's look at some other examples. Over here we have ammonia, right? So hydrogen, again, it just needs one electron to complete its outer shell. So it will form 3 single bonds with the central nitrogen atom. We know nitrogen is a group 15, so it has 5 valence electrons. So if 1, 2, 3 of them are used up in these single bonds formed with hydrogens, then we have a lone pair over here that completes the 8 electrons in the valence shell. It completes the octet. So ammonia is basically going to react with the hydrogen ion itself, which is again without electrons. It is electron deficient, and so this is going to form a new ion which is called NH4 positive, right? This is when ammonia reacts with a hydrogen ion. Like once again, this comes from the acid, right? And it forms this fellow over here, this polyatomic ion. And this is called the ammonium ion, right? So this is the ammonium ion. And this whole thing, again, will have a positive charge around it in square brackets. Right. Another example is carbon monoxide, a pollutant formed in the atmosphere by the incomplete combustion of fuels, right? So what happens basically is that the carbon and oxygen, they form a regular double bond, right? So you have 1, 2, 3, 4. So 2 pairs of electrons shared between them. We know that oxygen is in group 16, so it needs just 2 more electrons to complete its outer shell. So it will share 2 pairs of electrons, so it has a complete outer shell. So it will have 2 lone pairs. I'm just going to draw one of them right here, right? Carbon, on the other hand, has 4 valence electrons, right? And 2 of them have been used in bonding. So right now, carbon has an incomplete outer shell. It only has 6 electrons, 2 over here and 4 over here, right? So it needs 2 more. So where is it going to get them from? It gets them from the oxygen. It has 1 lone pair that stays as a lone pair. The other lone pair I was talking about that I haven't drawn yet comes up over here to form a dative covalent bond between the carbon and oxygen. So if I were to show this using those dashed lines, I'm going to have C and O, 2 regular dashes showing regular covalent bonds with 1 electron from each of the 2 atoms. But then we have a dative covalent bond with an arrow pointing from the oxygen to the carbon, from the source to the destination of the lone pair of electrons that is now being shared between them, right? So this, now you can see that we have 6 over here, 2 over here. So carbon has a complete octet. Oxygen also has a complete octet. Another example is AlCl3, right? So aluminium is in group 13, right? So it has 3 valence electrons. And chlorine is in group 17, so it has 7 valence electrons, right? So chlorine needs just one more electron to complete its outer shell, and to do that, it'll just share one pair of electrons with the aluminium. So show that over here. So all 3 valence electrons of aluminium are used up. It has no lone pairs. So you can see that the chlorine will have complete outer shells. Just draw them over here. Each chlorine atom will have 3 lone pairs and 1 bond pair to complete its outer shell. So all chlorine atoms will have complete octets, but the aluminium, you can see, has just 6 electrons in the valence shell after sharing. It has no lone pairs to complete the octet, so what will it do? So in this case, what happens is Al is electron deficient, right? This term that I've been bandying about so far, let me just write it down. It's electron deficient. So what it does is, normally AlCl3 or aluminium chloride will react with another AlCl3 unit to give you a larger molecule which is called Al2Cl6, right? And that's going to get rid of this electron deficiency. So we have another AlCl3 over here. What happens is the chlorine has this lone pair that will be used to form a dative covalent bond with this aluminium. Now the aluminium has a complete octet. And this lone pair from this chlorine will form a dative covalent bond with this aluminium in the other AlCl3 unit. These AlCl3 units that are combining together, we call them monomers, right? And when 2 monomers get together, this Al2Cl6, this combination of 2 monomers or 2 units is a dimer, right? So an Al2Cl6 dimer is formed using 2 dative covalent bonds, right, to complete the octets of the 2 electron deficient aluminium atoms, right? So this was dative covalent bonding. I hope you understood this concept, and if you did, do leave a like, share this video, and do subscribe to the channel as I said earlier, and inshallah I will see you in the next video.